Alright, in this video I'm going to show a couple of examples of solving oblique triangles using the sine law, and just talk to you about when you can use the sine law and some tips in using it. So first of all, you can use the sine law when you are solving an oblique triangle. And what is an oblique triangle? So oblique triangle means it doesn't have a right angle. Okay? So without a right angle. Okay, so two different possibilities of an oblique triangle then are: one, when all three angles are acute, and that means when all three angles are less than 90 degrees. The other option is that you have one obtuse angle and two acute angles. All right? So, obtuse means greater than 90, and therefore the other two angles would have to be acute because the sum of the angles in a triangle is 180 degrees. All right? So remember that. Sum of all angles, sum of three angles is equal to 180 degrees. We're going to be using that fact. All right. So here are a couple of examples of what does a triangle look like that has three acute angles. For example, it might be like this, and labeled A, B, C, and these can be in any order, where A is equal to 80 degrees. Actually, A looks a little more like it might be 55 degrees, and B is about 80 degrees, and C then must be 45 degrees. The sum of those angles is 180 degrees. Another thing to note, that when you are labeling triangles, that the angle and the side opposite it, which is the side opposite angle A, have the same letter. The angle, the capital letter is used for the angle, and the lowercase letter is used for the opposite side, which means that if this is B, then side B is over here, and if this is C, then side C is up here. All right, another example is when we have one obtuse angle and two acute angles. So an obtuse angle might look something like this. Where we've got, let's call this one B. Doesn't really matter which letter it gets. So A is perhaps 35 degrees. B is 120 degrees, greater than 90, obtuse, and C is 25 degrees. And I believe that adds up to 180 degrees. All right, so there are a couple of examples. When you have triangles like this, you cannot solve them with the trig rules that we've been working on so far. You need to use the sine law or the cosine law. And so using the sine law, it's possible to use the sine law. Here are some requirements. Let's just put this in another color. So, requirements for sine law. They are: 1, that you have at least one angle and its opposite side, and any other side. Okay, so you know one angle and its opposite side. Oops. I see what I did there. You know one angle and its opposite side. and any other side. Okay, the second possibility for using the sine law is that you know two angles and maybe you can kind of predict that if you know two angles, then you do know the third angle. So that means find the third by subtraction. And any side, because any side will be opposite one of these three. Okay, so those are two things to look for when you're deciding, do I use the sine law? So let's have a look at what the sine law is. Alright, so the sine law states that side A over the sine of angle A, that ratio is equal to side B over the sine of angle B, which is also equal to side C over the sine of angle C. And remember, it's important to have our triangle drawn or labeled such that angle is opposite side, angle is opposite side, and angle is opposite side with the same name. Okay, the other thing is you can also use these in their reciprocal, because sometimes if you have an angle that isn't unknown, it's a little bit easier to have the angles all in the numerator. So it also might look like this. Let's put it in a different color. Sine A over side A, sine B over side B, sine C over side C. All right, so that's the sine law. You can use it either way. The ratios will still be equal. Now what I'm going to do is show an example of how to use this. So let me change my color. All right, let's solve an oblique triangle, example 1. This is an example of knowing one angle and its opposite side and one other side. All right, so solving the oblique triangle, given we know that angle A is equal to 25 degrees, side A is equal to 210 centimeters, and side B is equal to 340 centimeters. Okay, so let's see now. We've got an angle and its opposite side. Good. Therefore, we can make up this ratio. So we have half of our equation. We also know side B, which means we can figure out angle B. We cannot find out anything about C yet, because we don't know either angle C or side C. So let's set up the equation. Now, noticing that I've got one angle, two sides, so it's an angle B that is my unknown. So actually, it's going to be best, but not limited to, me using the sine law just like this. All right? So sine A, I need to write sine of angle A, 25 degrees, over side A, 210, is equal to sine B, this is what I'm figuring out, over 340. Now just stop and think about this for a minute, because these are things you want to think about as you are solving the triangles. From what you know about triangles, if this side is 210, which is less than this one, then angle A will be smaller than angle B. Okay, angle B is opposite a larger side, so it will be larger than angle A. Just something to keep in mind. We should be getting an angle that is greater than 25 degrees. So let's solve this now. I would say cross multiply and divide. So I generally set cross products equal to each other, which is 340. Actually, we might be better off to start with the other side. Do the other product. So let's do this product first. 210 sine B is equal to 340 sine 25. And these are multiplied. I would like to solve for sine B, so I want to divide both sides by 210. Because it will cancel here, leaving sine B alone. Divide this side by 210. Sine B is equal to 340 times sine 25 divided by 210, which is equal to 0.6842. And the rest of the calculators is 3909. 3909. Now, you can round it to 4 decimal places. It's really best if you just leave this number in the calculator and then find out what angle B is. So B is equal to the sine inverse of 0.68423909, and B is equal to 43 degrees. All right. So B is equal to 43 degrees. Let's keep track of what's over here. We've got angle A, 25, B, 43, C, we don't know yet, side A, 210 centimeters, side B, 340 centimeters, side C, we don't know yet. What can we find out next? Well, since we have two angles, we can actually go and find angle C, which is equal to 180 minus 25 minus 43, which is equal to 112. All right. And let's write that in here. 112 degrees. Now we just need to find side C, and it's going to be necessary to use the sine law again. We are looking for this side. It actually might be better to solve it with the sides in the numerator this time. So to find side C, I'm going to use A over sine A equals C over sine C. Now write 210 over sine 25 equals C over sine 112. Cross multiply and divide, we end up getting here that C is equal to 210 sine 112 divided by sine 25, which is equal to 461, if I round it, centimeters. 461 centimeters. All right, so this triangle is solved. Now let's just take a look at our answers, make sure they make sense. The smallest angle should be opposite the shortest side. And we have 25 degrees opposite 210, that's the shortest side. The next largest angle is 43 degrees opposite 340, which is the next largest side. The largest angle is opposite the longest side. This triangle makes sense, and the angles add up to 180 degrees, and therefore we have it solved. I'll do another example in the second part.